Okay, welcome everybody. We're going to start off today talking about piecewise functions. This should be a bit of a review for most of you. If not, welcome. This is fun stuff. So using piecewise functions, we have two objectives here. The first is to evaluate piecewise functions, and the second is to graph them. Okay, so basically a piecewise function is a function that's defined by different equations on different parts of the function's domain. You've probably all seen these before. Maybe you haven't used that kind of language to talk about what they are. But I'll show you an example of one here real quickly, and you'll see what I'm talking about. So a piecewise function usually has these braces here, or one brace, I suppose. So f of x equals, and there's this curly brace, and it says it's the function negative x as long as x is less than 0. It's the function 0 if x is 0, and it's the function x if x is greater than 0. Okay? So basically what that means is that if I'm graphing this, I graph the negative x function, but I only graph it to the left of the x-axis. I graph the point 0 at the point 0, and to the right of the y-axis I graph the line y equals x. Okay, there's really three functions that are cobbled together, piecewise, cobbled together into one function. This is our favorite, our wonderful old friend, the absolute value of x, actually, right? Because if I plug in a negative number, okay, I plug it into this part because negative numbers are less than 0. What do I do with that negative number? It says right here, I make that negative number negative again, which makes the number positive. If my input is the number 0, I look at this, and that means my output is 0 because of that. If my input is a positive number, I look at this, and therefore my output is the exact same number. Okay. Let's look at a couple other functions that are maybe a little more complicated. So here's a function that's pretty straightforward, but maybe a little bit confusing. So if I'm putting in a value for x, if I'm asking about what is the input, okay, if I put an input in that is less than 2 or equal to 2, then I'm going to put it into this equation. My output will be based on this expression. If I put in a number that is bigger than 2, not equal to 2, but anything larger than 2, my output to the function is the number 3. Okay, let's give it a couple. Let's give it a shot here. So if I put in the number negative 4, okay, if I put the number negative 4 in, I'm looking at a number that is less than 2, less than or equal to 2 for sure. I'll get rid of these. It's a little hard to see. So for this one, I'm looking at a number that is less than or equal to 2. Okay, so I'm going to be looking at this part of the domain. What this tells me is that since the number negative 4 is in here, I'm going to use this as my rule to figure out the output. Okay, so here I do negative 4 into the top. So go negative 4 minus 2. Okay, well I think we can figure that out. Okay, so negative of a negative is a positive, so 4 minus 2 is 2. Okay, so I use the rule based on what my input is. How about when x is equal to 2? All right. Well, when x is equal to 2, which part of the domain am I going to look at? I'm going to look at this part of the domain because it's x less than or equal to 2. So I'm going to use this part of the domain. Therefore, I'm going to follow this rule to figure out what the output is. So again, I'm going to use the same rules I used above. Okay, I'm going to put a negative 2, or a positive 2. Negative of negative 2, you can see my group bonds there, minus 2 is equal to, 0. Pretty nice, right? Okay. And then finally, when f is 5. Okay, when f is 5, I'm going to put in, let's see, which part of the domain is that on? That is on the part of the domain that's over here, because 5 is greater than 2. So I'm going to use this rule to figure out what the output is. So if I'm putting in a number bigger than 2, my output is always 3. Oh, well that's not so bad. That means my output here is 3. And that's how we evaluate a piecewise function. Okay, let's look at another piecewise function. There we go. This one has 3 parts. We can have as many parts as we want. Okay, so we have 3 functions. X plus 1 is defined for values that are less than or equal to negative 1. This is the function we use if the input is between negative 1 and 1, including 1, not including negative 1. And this is the function we use. This is the expression we use to evaluate the function when x is bigger than 1. All right, so let's ask about x equals negative 2. If I put in an x value of negative 2, I'm looking at this part of the domain. That means this is the rule I'm going to use. So if I put a negative 2 in, I put it into the x plus 1. So I go negative 2 plus 1. So my output is going to be negative 1. Okay, let's look at the next one. F of 0. F of 0 is in this range here. So because of that, let me go ahead and get rid of this first stuff. Because of that, I'm going to be looking at this rule to figure out what my output is going to be. So I'm going to put in 0 into negative x, and I'm going to get, well, that should be pretty straightforward, right? I hope. Oh, don't want that. 0. Because negative 0 is 0. And then finally, we're going to look at 1. Now 1 is actually still in here, right? We have to decide, are we going to use this one, or are we going to use, we're going to use this top one, or this bottom one. Now, because we're using this one when x is less than or equal to 1, and this one when x is strictly greater than 1, if I'm putting 1 into the equation, into f of x, then I'm going to use this middle one here. So this is going to be the rule that defines my output when I put in the positive number 1. So I put in positive 1 and I take negative x, negative 1. Okay? So that's how we evaluate piecewise functions. Let's look at graphing piecewise functions now. Okay? I'm going to look at the exact same functions. Now this first one here, let's explain why the graph on the right is the same as this function here. What I'm going to do effectively is I'm going to graph two functions. Okay? I'm going to graph this function, negative x minus 2, and I'm going to graph the function y equals 3. Now here's how I constructed this graph. The first thing I did was I simply graphed negative x minus 2. So I used my knowledge about lines and I graphed that function. Right? Then I used my knowledge about lines and I graphed y equals 3, which is that line right there. Okay. After I did that, I looked and I said, well, these functions are defined in various places. The diagonal line is defined for values less than 2. Oh, this is backwards. This is negative 2 I've drawn.